Okay. So we're going to be doing class a little bit different this week because I'm going to be out the bulk of this week. Obviously you can tell this isn't really something we've done before, but since I'm going to be out about 4 days out of the 5 days of this week, I figured just so we were progressing and still getting stuff in and doing notes and that kind of thing, it made the most sense for us to do a video. That way you guys are still watching me teach. We're doing things about as normally as we normally would. It's just that you're watching me on Canvas instead of me being up here and teaching in front of you. Okay? So you guys should have a note sheet. All right? We're going to go through examples. We're going to look at 4.2 and 4.3. So we're going to look at multiplying and dividing monomials and powers of monomials. We're going to go through some examples with that. Give you guys a refresher since we had those 9-10 days off for spring break. And that way we can kind of progress and keep going and moving forward throughout this week. Okay? So, starting out, okay, example 1. We're asked to simplify we're asked to simplify x to the 8th times x to the 5th. Okay? So remember, as we're looking at these problems, okay, and we're multiplying monomials, we're looking for first the same bases. We see that x to the 8th and x to the 5th both have a base of x. So whenever we multiply monomials, what we're doing is we're adding the exponents. So I take x to the 8th plus 5, which gives me x to the 13th. Okay? So when I simplify x to the 8th times x to the 5th, I end up with x to the 13th. All right? So make sure you got that down. Give everybody a second to get that written down. Okay? Next one we have example 2. We are asked to simplify y to the 7th over y to the 3rd. Okay? So we simplify y to the 7th divided by y to the 3rd. So just as we did with the multiplying of monomials, we added the exponents. Here, whenever we are dividing monomials, we subtract our exponents. So I have y to the 7th over y to the 3rd. So I subtract 7 minus 3, which gives me y to the 4th. Okay? So simplified, it becomes y to the 4th. All right? Once again, I'll give everybody a second to get that down. And then as we move into example 3, we start to see some of the problems that we had a little bit more difficulty with as we were going through this, mainly just because we weren't breaking it apart and looking at each individual part. Okay? So example 3, we have 3x squared times 4x to the 6th. Okay? So we need to look at each individual part here. We have our coefficients first, and I want us to look at our coefficients first. 3 times 4, that is a problem that we know how to do. Okay? So we take our coefficients, 3 times 4 gives me 12. X squared times x to the 6th, we see that we have a base of x. I take the 2 plus the 6. for the exponents. So I get 12x to the 8th. Okay? We took the two different parts. We took look at the coefficient first. 3 times 4 gives me 12. X to the second times x to the 6th gives me x to the 2 plus 6, which is x to the 8th. So our final answer is 12 times x to the 8th. Okay? Once again, give everybody a second to get that down. Move on to example 4. Okay? Example 4, we're once again looking at dividing monomials. Okay? So, we have 16 x to the 7th over 8x to the 4th. Once again, we just have to look at each individual part here, okay? We see our coefficients. We know we need to divide those, so we take 16 divided by 8, okay? 16 divided by 8. Ignore this. 16 divided by 8 gives me 2. Once again, I have x to the 7th over x to the 4th. So I have the same base. So I take x to the 7 minus 4, okay? Which then gives me 2x to the 3rd, okay? 2x to the 3rd. All right? So like I said, we're just looking at this, we're breaking it up into a bunch of small pieces, okay? And we're just doing the things that we already know how to do, okay? Those base problems that we did in example 1 and 2, all right? The longer that these expressions get, we just break those down into smaller problems like 1 and 2, and then we combine it at the end, okay? Just like we did here. 16 divided by 8 gave me 2. X to the 7th over x to the 4th gave me x to the 3rd. Combine that, 2x to the 3rd. Okay? Example 5. Okay, we go back to multiplying monomials. Okay? So example 5, I have negative 5w to the 4th x to the 2nd times 2w to the 1st x to the 5th. Okay? Now, I could have just wrote this as wx to the 5th, okay? But we know that that w has a hidden exponent of 1, okay? Once again, let's break this up. So let's look at the coefficients. Negative 5 times 2 gives me negative 10. We have w to the 4th times w to the 1st. That's w to the 4 plus 1. We'll come back to that. Okay? Then we have our x's. Okay? We have x to the 2nd times x to the 5th. So x to the 2 plus 5. Alright? So negative 5 times 2 gives me negative 10. We already had that. W to the 4 plus 1 gives me w to the 5th. X to the 2 plus 5 gives me x to the 7th. So I have negative 10, w to the 5th, x to the 7th. All right, and that was example number 5. Okay? Once again, we'll give everybody a second to get that down. Example 6, it's pretty much like example 5, except we're doing division instead of multiplication, okay? So we do subtraction of exponents instead of adding exponents, but it's still got that type, it's still that type of problem where we're looking at multiple different parts, okay? 3 different parts. So, example 6, I have 72 x to the 5th, y to the 12th, over 9x squared y to the 5th. okay? It's a lot to say, all right? But once again, not there to intimidate us. We just gotta break it up part by part. So look at our coefficients. 72 divided by 9 is 8. Okay? Then we work our way to our x's. So I have x to the 5th over x to the 2nd. So I take x to the 5 minus 2. Once again, table that. We'll come back to it. Then I have y to the 12th divided by y to the 5th. So y to the 12 minus 5. Now we go back and we do that subtraction with our exponents. So I have 8x to the 5 minus 2 gives me 3, so x to the 3rd. Y to the 12 minus 5 gives me y to the 7th. So I have 8x to the 3rd, y to the 7th. Okay? As we go through that, all right? Example 6 is the last problem for the multiplying and dividing monomials. All right? So we worked our way through that. Okay? And then we get to example 7 through 12. All right? So examples 7 through 12, we start to look at the powers of powers and powers of monomials and things like that. Okay? So example 7, we have the most basic form of that. Okay? I have 5 to the 3rd to the 4th, so I'm taking 5 to the 3rd to the 4th power. All right? Remember, if we're taking the power of a power, we multiply, okay? We multiply our exponents. So here I'm going to take 5 to the 3 times 4, which is going to give me 5 to the 12th. Okay? 5 to the 12th. All right. Example 8 is the exact same type of problem, okay? Very basic, just one variable is all we're worried about, one power. We really don't have a coefficient. We don't have anything else like that to worry about. So we're looking at strictly just a power of a power. So example 8, okay? We take y to the 7th to the 8th power. Same thing, okay? Same thing, different base. We see power of a power. Power of a power. Okay, so I take y to the 7 times 8. Okay? That becomes y to the 56th power. All right? Feeling good? Give everybody a second to copy this down real quick. And then we move to example 9 through 12, and 9 through 12 is where we start to look at powers of monomials. So we're not just looking at base powers of powers like we have been in the past two examples, so we're starting to get a little bit more difficult. But like I said with some of the other problems that we were doing, okay, it's just a matter of breaking it up piece by piece. Don't let it overwhelm you. Just look at it piece by piece. So, example 9. All right. We have the quantity 5x squared to the 3rd power. Now, if this were x squared to the 3rd, I think that we'd be good. Okay, we'd be chilling. But we have that 5 in front of it. Now remember, that 5 has a hidden exponent of 1. Okay, because there's only one factor of 5 there. So what I'm going to do is I have to take 5 to the 1st to the 3rd, as well as x squared to the 3rd. So I take 5 to the 1 times 3 times x to the 2 times 3. Okay? 1 times 3 gives me 3, so I have 5 to the third times x to the 2 times 3, which gives me x to the 6th. Okay? 5 to the third, x to the 6th. And you can just kind of leave it like that. We know 5 to the third is 125. I could write 125 x to the 6th. We don't need to do that. Leave it like this. Okay? Once you get through some more higher level math, definitely start making that 125x to the 6th, but just for this, preliminarily, like looking at this very first section in which we're looking at exponent laws, don't worry about it. Okay? Example 10, same idea. Only thing that example 10 has that example 9 doesn't have is it has a negative coefficient. Okay? Negative coefficient. So example 10, we're taking negative 2y to the 7th all to the 9th. Now, I want us to rewrite this. Okay? Remember, negative 2, let's go ahead and put that in parentheses. Okay, with an exponent of 1. Alright? Because remember, if we don't put that negative number in parentheses, it can kind of make our outcome a little bit wrong and can kind of mess with the coefficient that we end up at the end of our answer. Okay? So remember that coefficient has a hidden exponent of 1. We go ahead, we add that to what we have here. Okay? So I'm going to take negative 2 to the 1 times 9, y to the 7 times 9. Okay? And so I end up with negative 2 in parentheses to the 9th power times y to the 63rd power. Okay? Once again, as you guys move forward in your math career, you can take negative 2 to the 9th and figure out what that ends up being. Okay? But for right now, just leave it as negative 2 to the 9th. All right? Got a couple more here, and then we'll be done with notes for the day. We have 11 and 12. Luckily, neither of them have any negative exponents, or negative coefficients, I mean. Negative exponents is what we get to talk about tomorrow. So you guys have that to look forward to. Okay? So, once again, we have 2x to the 3rd, y to the 8th, all to the 10th. Okay? Like I said in the past, this coefficient, hit an exponent of 1. Go ahead, hit it right from the beginning. Okay? It's going to help you out in the long run. So I have 2 to the 1 times 10, x to the 3 times 10, y to the 8 times 10. All right? We broke it down. We just looked at each individual part. So I looked at my 2, looked at my x, looked at my y. Here we are. Okay? 2 to the 1 times 10 is 2 to the 10th. X to the 3 times 10 gives me x to the 30th. And y to the 8 times 10 gives me 8, or y to the 80th. Okay? This is a fantastic example of why we don't expand these things all the way and then simplify. That's why we use these exponent laws. Because if you had to count 80 y's, okay, and I as a math teacher force you to do that, you'd be pretty upset with me. Okay? Last example here, okay? Example 12. All right. We have 8rs to the 5th, all to the 2nd. Take a second, look at this. 8rs to to the 5th. Okay? So 8, like we've said in the past, has a hidden exponent of 1. But in this problem, we also have to make note of the fact that r has a hidden exponent of 1. Okay? So this is 8 to the 1 times 2, r to the 1 times 2, and then s to the 5 times 2. Okay? So 8 to the 1 times 2 gives me 8 squared. Once again, as you move along, make that 64 right now. Leave it as 8 squared. We then have r squared. Then s to the 5 times 2 gives me s to the 10th. So 8 squared, r squared, s to the 10th. That's everything I have for today. Okay? Make sure that you guys return your earbuds to the front. Go ahead, clean them with those alcohol swabs. Make sure that they're all good and clean. Wrap up the cord. Don't just throw it in there. Okay? You guys have an assignment. Make sure that you guys work through that. We're going to start looking at 0 and negative exponents tomorrow. If you have any questions, go ahead and email me. Have a fantastic day.